Hi, this is Divya, and I'm working as an assistant professor in the Department of Biomedical Engineering at Sri Shanmuga College of Engineering and Technology. So, as the last video's continuation, we'll discuss about the numerical problems related to the thevenin's theorem. So here, look at the question. Find the current passing through the 24 ohm resistor due to the circuit. Here you need to find out the current flowing through this 24 ohm resistor. So first thing is we have to consider this 24 ohm resistor as a load resistor. Okay, this 24 ohm resistor is a load resistor because you need to find out the current flowing through the 24 ohm resistor. So you can remove this resistor now. The first step is you have to remove the resistor. So before that, we have to make sure that the Thevenin's theorem is proved or not, it is correct or not. So before that, we can find out the current flowing through this 24 ohm by using the mesh analysis. So here I have applied the mesh analysis. So if you're applying mesh analysis, you can form the first mesh equation as 10 equal to 14i1 and minus 12i2 and the next one is second mesh equation is 0 equal to, since there is no voltage source contained in the second mesh, you can make it as 0 is equal to minus 12i1 plus 36i2. Okay, so by solving these two equations, you can get the value of I1 and I2. You can get the value of I1 and I2. So here we got the value of I2 as 0.33 amps, 0.33 amps. So V24 ohm is equal to 7.92. That is nothing but by applying Ohm's law, V is equal to I into R. I value is 0.33 into R value is 24 ohm. So we can get the value of the voltage across 7.92. So voltage across 24 ohm as 7.92. So here the first step in the Thevenin's theorem, we need to find out the voltage across the open circuit terminals. The thing is, we have to remove this 24 ohm resistor. So we get the circuit like this. You have to remove this resistor and keep these two terminals as open circuit. So now you need to find out voltage across these two terminals. So the voltage across these two terminals is nothing but the voltage across the 12 ohm resistor, right? So when the load is disconnected from the circuit, you will get the resistor like this. Circuit like this. So you need to find out Thevenin's voltage, VThevenin. VThevenin is nothing but VAB, voltage across VAB, that is voltage across the 12 ohm resistor, right? Okay, now you have to apply the voltage division rule to find out voltage across this 12 ohm resistor, because a single voltage source is connected across the seriously connected two resistors. So if you want to find out voltage across an individual resistor when two resistors are connected across a voltage source, you have to apply the voltage division rule. So voltage division rule is nothing but total voltage into the resistor across which we need to find out the voltage. That is, we need to find out the voltage across this 12 ohm resistor, right? So this 12 ohm divided by the total resistance. The total resistance is nothing but 12 plus 2, 14. So which is equal to 8.57 volt. So VThevenin is equal to 8.57 volt. So this is the voltage across the 12 ohm resistor. That is now voltage across the open circuit terminals VAB, and that is the Thevenin's voltage. And the next, how can you find out the Thevenin's resistance? So you have to short circuit the voltage sources. If it is a voltage source, you have to remove it by short circuit the two terminals. You have to remove the voltage source and you have to short circuit the terminals. So you will get the resultant circuit like this. So you need to find out the Thevenin, that is Thevenin resistance, you need to find out the resistance RAB. You have to look from this side. While looking from this side, you will have two resistors, right? You can see two resistors, 2 ohm and 12 ohm. So how these 2 ohm and 12 ohm resistors have been connected? So these 2 ohm and 12 ohm resistors have been connected in parallel. So you can look at these resistors. The two ends of the two terminals have been connected with each other. So you can say these two resistors have been connected in parallel. So you need to find out the R equivalent. How can you find out R equivalent for two parallelly connected resistors? So two resistors value, you have to multiply the two resistors value divided by sum of the two resistors values. So you have to multiply the two resistors value, 12 into 2 divided by 12 plus 2, which is equal to 1.71. So this is the R Thevenin voltage we'll get. And now we found both the VThevenin value and R Thevenin value. The next step is you have to make the Thevenin's equivalent circuit. We have to make the Thevenin's equivalent circuit. How can you find out? Make Thevenin's equivalent circuit. The Thevenin's equivalent circuit will consist of a voltage source and in series with the resistance. The voltage source value is VThevenin value, and the resistance value is R Thevenin value. Okay. So we can make the circuit diagram like this, and the next thing is you have to connect the load resistance with this. Load resistance is nothing but the resistance value across which we need to find out the current or voltage. So 24 ohm resistance you have to connect that, and now you need to find out the current flowing through 24 ohm resistor. How can you find out current flowing through 24 ohm resistor? V divided by R by applying Ohm's law. V by R. So V value is 8.57 divided by R value is 24.17. 24 plus 1.71. So which is equal to 0.33. So here we can check whether the answer is correct or not by using the previous thing. Previously, we have found out the value by using methodologies, right? So you can verify it now by checking the answers. So both the things are same. So here the Thevenin's theorem is verified, and we need to find out the value of V24 by Ohm's law. V is equal to I into R. I value is 0.33 into R value is 24 ohm, which is equal to 7.92 volts. So that's it. That's it about the Thevenin's theorem. So by using Thevenin's theorem, in this way you can find out the current flowing through a particular resistor or voltage across the particular resistor. So the first thing is you have to remove the load resistor, and you need to find out the voltage across the open circuit terminals. That voltage is the Thevenin's voltage. And the next step is you have to remove the voltage source by short circuiting the terminals. So you need to find out the Thevenin's resistance, and by after finding out Thevenin's voltage and Thevenin's resistance, you can make the Thevenin's equivalent circuit. You can make the Thevenin's equivalent circuit by voltage source and the resistance, VThevenin and the Thevenin resistance, and by connecting the load resistance you can find out the simplified Thevenin's equivalent circuit, and after that you can easily find out the current flowing through the load resistor. So this is the way how we can use the Thevenin's theorem to solve the problems. We can simplify the complex circuit in a simplified equivalent circuit. We can simplify the complex circuits. Thank you. Bye.